At SAS, we love bold questions, outrageous and impossible questions. The answers are waiting to be discovered because space isn't the new frontier. Data is. And with the right questions and the right analytics, we make data do amazing things. Like make the world safer, faster, healthier, and kinder. All we have to do is ask the data, analyze it, shape it, and make it work smarter for everyone, everywhere. With SAS, you can turn data into answers and ask the questions that move the world forward. SAS, curiosity forever.
Welcome everybody to this new DNA Cafe, which stands for Data and Analytics Cafe. It is cooking over here, and the theme of this DNA Cafe is what's cooking? What's there going on in innovation land? So welcome everybody, all our guest speakers and the guest speakers here on the back. We have a marvelous program this time with 3 innovations and all their innovators sharing their stories. Please put off your mic and your camera so that we have the best broadband connection. If you have a question or a remark, put it in the chat. Over there we have our chat moderator Hera Blokhuis, our managing director of SAS Benelux. So he will take care of everything, and if needed, he will interrupt me for things going wrong or can improve. So the idea is that we have 3 sessions with table changes, and that after, let's say, a talk of 10 to 12 minutes, we have a Q&A so that we can address the questions and remarks you have put in the chat. All right, then, without further ado, let me introduce Frank Dietvoorts and Bart Geerts. Frank Dietvoorts being the managing director of PW Consulting, and Bart Geerts being the CEO and founder of Health Plus AI. Let's start with you, Bart. Health Plus AI, it's all about post-operative infections and working with AI. Please explain, what are you doing with your team?
So our team, we work on data models, or models rather, that predict infections after surgery. So sorry to break it, for a lot of people this is probably unknown, and maybe better even to not know it at all. But 1 in 4 to 1 in 5 patients that get a surgery, and that's about 300 million people worldwide.
300 million people worldwide.
That's too little because we have access problems to healthcare in a lot of places. So basically what we see is that 1 in 4 of those people run into an infection, a pneumonia, a wound infection, those kinds of problems.
All right, and so what can AI contribute to this problem?
Yeah, so what we see, my background is in the hospital. I'm an anesthetist and intensive care physician, and what I found on a day-to-day basis is that we see patients days after the surgery. On average, the diagnosis is made on day 5, and what we thought was, what if we would know earlier?
Yeah,
put in an intervention earlier. Can we reduce the impact of the infection or even prevent it?
But how come that AI, artificial intelligence, can be that clever to know on beforehand what will happen?
Right. Well, I think there's a couple of reasons. One is there's a lot of data. As a doctor, you see about 50% of all the data that's actually available. Mm-hmm. So it's hard to integrate everything. The other thing is there's complex patterns going on. And moreover, an AI can look at millions of patients, while I, as a physician, maybe see 20 to 50,000 in my lifetime.
Yeah, so like Tesla, you make use of all the experiences worldwide, because it's a lot of data. You have to crunch it, and with the help of AI, that's feasible. And then it's rather complex. In what way it is complex?
It is complex because infections pop up without you knowing. Everyone behaves slightly differently, but there are some mainstays there. And those complex patterns, those pathways, those trajectories, you can recognize with an AI. I think that's the predominant problem there. Another problem is that we have junior doctors running the wards, and the senior physicians are doing the surgeries. So there's also a gap in the right experience at the bedside.
Right, I see. And you mentioned also in the press release we saw a few weeks ago that it's quite costly not to prevent this kind of infections. In terms of what kind of costs?
Well, it depends on where you are, but on average, $15,000 or 10,000 euros is about the range that you will see
per patient.
Per patient that has an infection.
And then how many patients worldwide?
Well, do the math. We say it's about a $0.5 trillion problem.
Whoa, this is huge. This is huge. All right, I'll come back to you. Frank, I remember very clearly, it was somewhere last year that we phoned you because PW Consulting is one of our appreciated SAS partners. What was this phone call all about?
It was about asking us to help develop a production version, a robust version of the Periscope environment to help the certification process of getting Periscope ready for the market. And we were actually immediately interested because we have a lot of experience in healthcare and life science. And this is also an opportunity to contribute to the quality of healthcare. And that's something meaningful. And that's helpful to generate the energy, the positive energy to contribute to this multi-year program.
And PW Consulting already for years has deep expertise in the healthcare market. What specifically will we work on together in this collaboration, SAS, PW Consulting and Health Plus AI?
We do have a lot of experience in life science and healthcare, and we are around since '88, so we have a lot of experience as well in developing solutions. And that's actually what we're doing together at this moment, using SAS as a very advanced toolkit with all the functionality in it to develop a solution able to help Periscope do its analysis and scoring in multiple hospitals. So the scalability and the robustness of the environment is very important. And in such a process, make it through the certification process and then ready for market. Right. So it's a solution, actually, we're developing a solution together.
Together developing a solution. And you mentioned the word Periscope. Periscope, what does it mean?
Give the baby a name.
Just gave the baby a name. Yeah. And so the aim is to develop Periscope as a solution in a multi-centered way to distribute worldwide. Exactly. Am I right?
Exactly.
Right. Yeah. So on May 7th, we were really happy because then we got this phone call of, I think it was Mark van Marken of the municipality of Amsterdam. And he was the one taking care of this program called EU React. 1.27 million euros for the next 3 years. What are we going to do with this money?
Well, it seems like a lot of money. It's probably a lot of money. But it is footing part of the bill of getting to a well-governed tool that can be scaled and needs to be certified as well. So there's a lot of items that we need to tick and get done before we actually get there. But it's a great facilitator, a great start of this project. Yeah.
And that takes 3 years.
Yes.
That's what it takes. What are the main challenges now for the project team, Frank?
I think the most important thing is to have, actually the intelligence of the model has been developed quite well. So that's something we need to lift to a more production ready maturity level. But the main challenge is now to do it in such a way that ideally without any needed support locally in the hospitals, because that's the first phase, that it needs to be run locally. Having an environment that's fully reliable, auditable, totally governed and traceable, and all the results are in such a way auditable that you can always be certain that what you get can be traced back to the original data, but also that you don't have to provide support, local support, to have the environment doing its job.
Yes, because that's quite tricky when you really operationalize it.
Yes.
Because there are a lot of startups working on proof of concepts, but actually you are now moving ahead and making a product, making a solution together with SAS and PW Consulting. And all this under the umbrella of SAS DNA Lab, which is actually the reason why we are there, because this is not a commercial trajectory yet. We are working on innovation, frontier innovation, and together we'll make it feasible to make commerce in the end. Yes. And this will help every patient worldwide in the end by predicting. All right, so one more question from my side. there are a lot of trajectories and hospitals going on. There are a lot of startups. You've chosen to create a consortium, to co-develop, to co-innovate. Is this the new way of bringing AI to the bed of the patient?
I hope so, because I think it's the only way, or it is actually the most feasible way. I've pitched what we've been doing in the prototype phase. Of course, you do open source and you try to get there quickly. But if you start looking at all the things that were just mentioned, that requires actually a lot of experience, a huge organization. And in a way, some people put it to me, what you're trying to do is 3 companies. Well, that's where we are.
And that's
right?
where, so the collaborative strengths of us. So, Heren, hello, Heren.
Yes, Arthur.
Can you tell us, are there already some questions in the chat?
It's been very quiet in the chat, but question now dropping in. So let's first go to Jos van Dongen. Jos, can you please open up your mic and start your camera and ask your question?
Sure, no problem. It's about cloud, so I assume it's a cloud-based solution, is that correct?
It is and it isn't. It depends on what ultimately the client wants. So in the US, cloud is more accepted by hospitals, so there would be a full yes, I guess. But in the Netherlands, we see that you need an on-premise solution because people are not ready yet to move their data to the cloud, or not always.
Okay, well that answers the second part of my question as well. So it's a hybrid solution and hospitals can run it on-premise if they want to.
Yeah. Exactly.
Okay, and there's no additional benefit for them to move to cloud, or?
Well, of course, we can incentivize it as far as we can, but we do see a change, though. With COVID, I think opinions did change quite a bit. Normally, in terms of IT, but also other developments, hospital care systems are behind by 5 years compared to the US. So where the US, 60, 70% or something like that, has moved to the cloud in recent years, I think that's what we'll see as well in the Netherlands, but with a bit of a lag. So it might actually be just to bridge that period, but we're going to do it anyway.
Okay, thank you.
Let's move on to the next question. We have Serena. Serena, if you can open up your mic and start your camera and ask your question.
Okay. Hello. Yes. So I was just a little bit curious. What were when you were going through your open source strategy, what were the exact pain points?
Well, if I can take that one with anyone can answer, I guess. The pain points were more on the hospital side. How can you standardize the data, the inputs that you're getting? How can you make sure that you make that process easy? How do you facilitate that? If you ask a lot of questions to the IT department, which is already overwhelmed in most hospitals, that is ultimately your challenge. So we found a couple of hospitals that were willing to put in a lot of time, but that's not going to be the case always. So that's really the standardization, the automation, ingesting the data, that ultimately we see as the biggest bottleneck. And we saw that already in the prototyping phase. I hope that answers your question.
Yeah, thanks.
Thank you, Serena. We'll move to Michiel Klein. Michiel, can you open up your mic because your camera is already on?
Yeah, sure. How long did it take to create Periscope?
I think about a year, 1.5.
Right, and what were the learnings during this period that you discovered? What were the biggest challenges?
Well, good instruction.
Yes.
I lost my voice.
You lost
Sorry,
your
I lost my
voice.
voice.
Okay.
Sorry.
So it took 1.5 years.
I'm vaccinated, by the way. So
it took 1.5 years.
It took 1.5 years, and I think the biggest bottlenecks were actually legal, to be fair. Coming to understand how you use the data, what is actually private data and what's not, and setting up the process. So ultimately, we got actually approval to take all the data to the cloud. And that whole process, I think, took the longest, actually, and putting that into operations. That was the challenge. So basically a lack of experience on both sides on that matter.
Okay, thank you, Michiel and Dodder, for asking the questions. Over to you, Arthur. These were all the questions in the chat.
Yeah, thank you very much, Heren. So, a last question from my side. What do you want to share with the audience before we leave?
I would say keep up the innovation. It's very worthwhile and there are very interesting things to happen.
Bart, any comments?
Can't say any more than that. Keep innovating.
Thank you very much for joining this cafe, sharing your stories, and good luck for the next 3 years to build this solution. And I wanted to thank Innovencio as well, the partner who helped us guiding through the process of the application and getting this grant.
Sure.
So thank you very much, and then we'll have a table seating.
And thank you, Arthur, because the DNA lab is also important in this.
Yes, and I'm really happy that we really can thrive on this kind of innovation. So thank you very much, and happy forward-looking.
Okay.
Thanks.
Bye. All right, then may I invite Bert Rijk, CEO and founder of Aurea Imaging, and Merel van Sommeren, account executive at SAS and Innoventure ambassador of SAS DNA Lab. Bert. Aurea Imaging. We already know each other for quite some time. You were one of the startups at Robo Valley. At the time, you were collaborating with a drone company. Where did the whole story of Aurea start?
Yeah. Thanks for having us here, Arthur. It was a pleasure. So basically, Aurea started, well, I guess 32 years ago when I was born on a farm in Flevoland.
All right.
I always had this enthusiasm for agriculture. Studied in Wageningen, like you, and actually Merel also did, of course. 3 alumni here
on the table.
Exactly. Go Wageningen. No, it's just. So I studied geoinformation science, which like spatial IT, I would say. Things like Google Maps and TomTom, they run on spatial analytics. And after I was graduated, I wanted to do something using technology that could help agriculture. So I started a drone company. Actually, I worked for 6 months for a job, and then for a boss, and then I started my own company. So that was about 5 years ago, and the goal is still with our team of GIS experts and data scientists, basically to help agriculture advance and get more sustainable.
And make it smart. The smart farming, that's actually what it's all about.
Yeah.
Am I right? Right. And what did you study, Merel, in Wageningen?
Well, I wanted to hear more from Bert.
Oh!
No, but what I studied rural development economics. Right. So the plan was for me to not live in the Netherlands, but here we are. But we studied at the same time. So I know Bert from back in the day. We're not that old. I studied in Wageningen, and I always had this passion for like the food security topic. How can we produce enough food to feed the world? And I think that's where we have a really good fit here. And I hope you'll touch on that later.
And please explain for all the people in the cafe, what's your role now being an Innoventure ambassador for SAS DNA Lab?
I love that word. The Innoventure ambassador.
Yes, it's an adventure, becoming a venture.
So I'm an account executive at SAS, and I think I discussed this with some colleagues here as well. We're basically the link between the really smart people at Aurea
out there,
and the really smart people at SAS. We make sure that they come together and that they really collaborate and come to really smart solutions. And I think this is definitely one of those really smart solutions from SAS and Aurea.
Let's step into that. What makes the solution you're working on smart? And what are you working on anyway?
So that's a good question. So agriculture in general is quite under pressure, and imagine being a plant out in the field all these days with 35 degrees. So climate is definitely challenging, but there's a lot of different things that the consumers want more healthy food, but they don't have the budgets always to pay for it. There's biodiversity, of course, environmental emissions. So agriculture is it's quite pressured, and at the same time, agriculture is it's a bit conservative. I wouldn't say they're not smart, but they could definitely be smarter. So growers currently, they manage basically their farm more or less as one unit, whereas farms are usually a lot of different fields, but actually a lot of different trees. So if we look at orchards, there's about 3,000 apple trees in an orchard, and more or less everybody is every one of them is a bit different.
Every tree is different, you mean?
Yeah, exactly. So there's trees like you can see over here that have no blossom and therefore no production, but they get the same amount of fertilizer and irrigation as trees that are filled with blossom, like you can see on the image over here. And so those are currently all managed the same. They get the same fertilizer, the same pruning, the same irrigation and everything. Whereas there's between basically between 5 and 100 tons of production per hectare between different trees. So there's a huge amount of difference.
That's a major gap.
Yeah.
And what is then your solution about? And what's the smart aspect of it?
Yeah, so what we do is we place a lot of sensors in the orchards. There are sensors in the soil measuring moisture and temperature, and there's weather sensors, of course. But there's also drones. We fly a lot of drones, creating 3D models and infrared images of the orchard, and sensors mounted on tractors as well. And they're monitoring and measuring every tree basically throughout the year. So the tractors, they drive around about 30 times per season. And then every time they measure things like how big the tree is, so volume of the tree, the amount of blossom that every tree has. And our sort of framework, a digital twin, can integrate all of these data sources.
Wait. Digital twin? Please explain.
Yeah. So you can imagine it's quite complex. And just to give you an example on blossom management. So the optimal amount of fruits of one tree is around 100. So one tree can bear 100 fruits. If you don't do anything, it's between 3 and 300, more or less. But the optimal amount of fruits per tree depends on how big it is, but also on how much fruit it gave last year. And so it's a complex world. And currently this all goes. These decisions are taken in the head of the farmer or the agronomist. And basically, we want to give them more tools to manage and make those decisions on a tree level. And digital twins is a sort of framework where all of this integrates.
Okay, so you're actually making kind of a copy of every tree in the digital world, and then you can spot on what does this tree need, and then you can have the right interventions. And we see here the tractor. This is one of the tractors of Kubota, I think. You started a collaboration with Kubota. And now you started exploring with us a collaboration with SAS DNA Lab. Why are you reaching out to Kubota and to SAS?
Yeah. So what we saw is we started this. We started this with enthusiastic data scientists and a few people with some agricultural background, and that is enough to use some open source tools and. Yeah, basically to create some initial models that function quite well, but it's relatively hard to scale. And so, as an example, these sensors, they could be mounted on Kubota tractors. Currently, we use a lot of drones that fly over the orchards, but it's operationally it's a lot easier to mount them on the tractor.
Right.
And so for us, it would be ideal if companies like Kubota or others out there if they would just by default out of the factory, off the shelf, place these sensors on their tractors. Then we run the analytics, but scaling this operationally from models that work once or twice to a robust system with thousands or tens of thousands of tractors monitoring the system is quite challenging.
Because you are quite ambitious with your team, you will conquer the world. Actually, you told me lately that you're now active also in, was it South Africa?
Yeah.
What are the countries you are now active?
Yeah, definitely. So we started in the Netherlands, of course, but we stretched that a bit to Northwestern Europe. But we're currently got clients in like the main fruit growing regions. So that would be Chile, the big one, South Africa, New Zealand. We're running in pilots in North America as well, and other parts of Europe. And so that it's got a few advantages because besides, of course, the market size and the commercial opportunities, it's that agriculture can be challenging for developers because some occasions or experiments can only happen once per year. Like Blossom is only once per year. And so if you've got North and Southern Hemisphere, you got 2 seasons per year. So basically speeds up your development by 2.
And that's actually what happened this spring as well. You were collecting data. We were already involved in how can we crunch this data, how can we optimize the collection of the data so we can manage it later. And then you find out that, well, we should adapt some of these. Here on the picture, we see a workshop which was there last Tuesday, and Mira and I, we were invited for lunch, which was really great. But in the morning and in the afternoon, you were there with your geeks, with your data scientists and ours. What did you discuss, and what were the results of this discussion?
Yeah, I'm not sure if they like it if you call them geeks, but they're...
They're really smart people.
I see here nodding.
Really smart people.
All right, your data scientist not.
General remark, no, just kidding. No, so indeed, we run all of our analytics in the cloud currently in a central location, mainly using open source tools. And the next step for us is to bring these analytics to the edge. So we're developing this sensor system that can not only acquire data but also process it locally. And these sort of sensors, they can literally collect terabytes of data per day.
Per day.
Yeah, per day. So having to transmit and process all of these images to the cloud, that can be quite challenging, especially in agricultural regions. So let's say one tree, like we see over here, it can produce from a few megabytes to, let's say, 50 megabytes per tree, and you've got 3,000 on a field. Whereas what you're only interested in is how much blossom that tree has. So you go from maybe 100 images of that single tree from different angles, you go to the value 2 or whatever. So doing that on the edge has a lot of benefits. And SAS has some great tools for bringing our cloud-based analytics to the edge. We're in this demonstrator. It's trying to achieve that.
And I think it was ESP, event stream processing, being discussed about as well. We already talked about it earlier.
Yeah, definitely. Yeah, I think we used a number of tools from SAS, but indeed there's camera streams, but there's also GPS streams. Some cameras have depth images, and all of these streams need to be integrated in real time and processed to something useful.
And what came out of this workshop, and what are the next steps for the coming month?
Yeah, so we, as I mentioned, the blossom season is more or less over. So we might ship tractor or at least the sensors to the southern hemisphere, but it will still be October until the next blossom season. So that's one of the challenges. The next goal that we set out, because we of course want to do more than just detect blossoms. The next goal that we set out to be to be feasible in the short term is to count and size the amount of apples. Can be done using the same sensor system around August. So the next goal is to have a completely operational setup, sensors, edge processing, analytics, and to count the apples per tree and the size per tree, which is useful for farmers for logistics, for marketing reasons, for planning of employees and picking crew, those sort of things.
If I take you 5 to 10 years ahead, what are you dreaming of? What is your horizon 3?
Yeah, so we see already slightly coming in from the greenhouse world that there will be completely autonomous orchards. So you see that currently still there's a lot of complexity in growers. Of course, have got a lot of experience, but for those of you who are interested, if you Google for the Autonomous Greenhouse Challenge, you can see that out of the 5 teams, which one was a team of growers reference and 4 AI teams, that the first year there was 1 team that outperformed the growers. One AI team that outperformed growers.
Right. The
second year, all of the AI teams outperformed the best growers and agronomists out there. Of course, it's a different world. It's a lot more controlled environment. You can add CO2 and light if there's a shortage, which is different from orchards. But it's definitely what we see happening as well.
So actually you're creating kind of Tesla kind of technology into the orchards.
Yeah, it will be autonomous driving. It will be unmanned robots.
Interpreting, making interventions.
Exactly, and big crop intelligence algorithms to crunch all the numbers and to optimize per tree.
Wow, this is great. And when I take you 5 to 10 years from now, you're not working together with Bert on how do we create a collaboration framework?
Because the collaboration framework will be there already. Yeah.
And so what will we see in this joint effort for the next 5 years from a SAS perspective?
From a SAS perspective, I really hope that you, of course, grow and get really, really successful. And with that, we will take this startup, scale-up situation and make sure that we have a sustainable future for DNA Lab, where you guys pay for your licenses, and with that, we create a sustainable fund for the startups.
So actually creating kind of a revolving fund so that we can help the next generation of startups.
Yeah. And I would totally see this go worldwide.
Yeah. All right. I think we are running not out of time, but let's have the chat here. What are the suggestions or questions in the chat?
Yeah, so there are 3 questions. So let's first move to Claire Juliette. If you can open up your mic and start your camera and ask your question.
Sure, I'll be very brief. Thank you. Great session, by the way. I'll start with that. Thinking about agriculture, one of the things that come to mind is agricultural folks typically are very cautious and careful. At least they have been. So do you see the same thing? And maybe it's a question of generation change. Maybe the younger ones would be different. Interested in your feedback.
Yeah, good question. I think the proof is always in the pudding, and even more so maybe in agriculture. So this example of these autonomous greenhouse challenges, where actually 4 teams of AI, they showed that they can outperform growers. That was, for those growers, it was really was a big eye opener. So I do think that the younger generation in general is more interested in this. Interestingly enough, it's usually not the youngest farmers, because they're just taking over their family farm, and they're just trying to get their head around all of the operations out there. It's also not the oldest generation, because they'll just leave it to the younger generation. So it's usually, I think, the generation, let's say between 35 and 50 more or less, that's got comfortable enough on their organization to spend time on innovations, but they're not old enough yet that they see this as something for the newer generation.
Thank you. Makes perfect sense.
Let's go to one more quick question and then we'll move on. So I'll move to Mathieu. Please open up your mic and start your camera and ask your question.
Yes. Hi, very nice to have you here. Thank you for this nice talk and good to see you again. You pointed out that that smart farming can optimize the yield for farmers, and I can imagine that currently, there are, at least in the Netherlands, a lot of discussions about nitrogen usage and to reduce that. Can imagine that you can optimize this, but what would be other benefits of smart farming?
Yeah, good question. I think indeed things like nitrogen, actually we participated in an experiment last year and our data showed that adding more nitrogen doesn't make any sense in terms of yield improvement, whereas farmers always thought that the more the better. So things like insights like that does more is not always better, and actually it had a negative impact on yield quality. But there's maybe one or two things. I think the Netherlands doesn't have any drought issues yet, but I think globally irrigation and water will be a very big topic. And countries like South Africa, they're already struggling because they like wine is one of their biggest exports, of course. But what they basically export is water, which it took a lot of water to produce wine, but wine is not 99% water. So there's a lot of struggle and discussions on how much water should we allocate to farming. And that's also, of course, where water saving technology can come in. The other one maybe is labor. We saw already with Corona that a lot of the pickers and a lot of the pruners that usually come from Eastern European countries, that they didn't want to come, they couldn't come. But just in general, this is a trend that agriculture labor is getting scarcer and more expensive. So those are definitely other challenges and benefits basically to achieve using robotics and automation.
Interesting, thanks.
Thank you, Mathieu, for your question. There are many other great questions. We don't have time to answer them. I'll find a way to answer them in a different way. So back to you, Arthur.
Thank you, Hera, and thank you very much, Bert and Merel, for sharing these insights and looking forward to our cooperation. Thank you very much.
Thank you.
Right. And then we have a change of table. And may I welcome Rob Michels and Casper van Been of RWS, Rijkswaterstaat. Welcome. And Rick de Ruiter, data scientist at SAS and one of the powerhouses in our SAS DNA lab. Meanwhile, some pictures here on the back. Paul, our master chef, he is preparing some great food for the after drinks. Okay, what's cooking? What's cooking at RWS? Rob, can you introduce Rijkswaterstaat? What is it all about? Mainly also for the international guests.
Yeah. RWS is a part of the Dutch government, and we build and manage roads, waterways, the water system. That's very essential for us. We have a large part of our Netherlands is far below sea level, so it's a very important task to keep us safe. And in this environment, we have lots of sensors, lots of data. In the past years, we had data collection solutions for all kinds of systems, lots of them. And it was about 2018 that we said we want to have one data collection system. And for all kinds of data, real-time, video, sensor data, all kinds of data. And that we have done. So,
wow, so 3 years ago you started this project, actually.
Yes.
A program, you might call it a program.
Yeah.
Yeah, and you're the program manager.
Yes, I do.
Yes. And with you is Casper van Been.
Yes.
What is your role at RWS?
I'm Rob's technical manager for the data collection program. And basically Rob makes sure that we get either projects or challenges to do, and I have to figure out with the rest of the team how to get a solution to, let's say, all the different challenges we are getting.
And then one of the use cases you're working on is the topic of today. Can you help us? What is it?
Yeah, we're just a couple of at the end of last year. An asset manager from the northern part of the Netherlands came to us, Willem Wouters, and he wanted to know what kind of traffic, what kind of ships were going to and from the northern part of the Netherlands. And so he had a location where he said, I want to know what kind of ships are passing here. I want to know how broad they are, how high they are, how fast they are going. Are they going against the stream? Can you guys with your, he basically teased us a little bit with your data collection chain, can you give us a solution for this specific question? And that's where we pretty fast ended up with a LiDAR based solution. And then it gets a little bit really technical and we need some help from SAS.
And we need some help from SAS. And LiDAR, please Rick, help us. What is LiDAR?
Yeah, LiDAR is now found in the latest iPhones and autonomous vehicles. And it helps you to map terrains and objects with very high precision.
And what's the difference between LiDAR, radar, photo cameras? Help us out. What is this?
So LiDAR is actually very similar to radar, but radar uses radio waves and LiDAR uses laser pulses. And it helps to make it more precise.
All right, and so then regarding the use case, what is the role of SAS?
So our role was really on the analytics side. So we have this LiDAR system, but how do you translate that into insights?
Right. Well, and that's what we do all the time.
Yeah.
So what makes it so special that we are now here around the table talking about innovation?
Well, a LiDAR system really generates tremendous amounts of data. So this LiDAR sensor, I think it was 655,000 data points per second.
Again, 650,000 data points per second.
Yeah, 655,000 data points per second.
All right, and then what happens to this data?
So yeah, you need to do something with it, otherwise the value is lost, of course. You need to do analytics right away.
All right, describe the project.
So once we got the LiDAR system, we had some field trips, we went picnicking.
You have a picture on that,
yeah.
Isn't it?
So we went to the Amsterdam Rijnkanaal, for example, and we started to collect some data and to develop a feel, what does this data look like and how can we build a model on top of this data?
This is innovation, this is just pioneering. I think even in your leisure time.
Yeah, I would do so, yeah. Definitely.
All right, and what do we see here on the pictures?
So after we were sure that everything would work, we installed the LiDAR system in a permanent location, which we could only access by boat. So we really wanted to make sure that everything was up and running. Yeah. Also, we didn't have an internet connection there. So we could use 4G, but there was no internet cable there. So that also meant that we had to process everything in this log.
In the
log.
In the log.
So on site. Yeah.
On site, in the log. Yeah. You had to process it there.
Yeah.
Not on the edge, but in the log.
Yeah.
Right. And then?
So yeah, we got this small device. It's an edge device.
Can we see it clear?
Oh, yeah.
And turn it a bit. So what is this device?
So this is a small edge device. It's basically a mini computer. And we had to process these 655,000 data points per second using this device.
Just this small device. Right. And you had to do it. And did it work?
Eventually, yes. So we collected a lot of test data before and yeah, we got it up and running relatively quickly. Yeah.
All right. And then Casper, what's the next step once you have collected and let's say processed this data?
Yeah, basically because we have the generic data collection, now it is a LiDAR system, but we also have different kinds of systems within RWS which read transponder data from commercial ships. So what we can do now is connect those two together. So when a ship is passing, you can basically take data from another system, right, and basically immediately say, okay, this is this ship, this is the captain. If he goes against traffic, we might even give him a small letter saying that please don't do that anymore. We're not allowed to send fines, but we can send him a letter saying that's not a good idea. So that's something we can do with this technology. We can use the same technology to try to make parts of the road safer, just by monitoring it, making sure that everything is safe before a bridge opens or something.
So what you're now here actually inventing is something you can use as an application in other fields of RWS as well.
What's happening, Rob is getting a lot of attention with all these kinds of projects, so he's getting more and more in, and we're basically tying all different kinds of technologies together now. And that's something that, with the help of event stream processing, actually makes it possible that we can combine different data streams that 5 years ago people didn't even think of combining road traffic data with waterway data. It was technically not even possible.
Earlier in the previous one, we talked about ESP as well, event stream processing. Can you explain us a bit more deeply, Rick, what is ESP all about?
ESP is really about real-time analytics. So, and you can also deploy it on edge devices. So ESP is actually running on this device.
So, and that's what you really need to create this overarching kind of monitoring of all these data sets bringing together. And that's actually matching your goal of creating this great data, you might say data lake, or it's a data platform.
It's a data store.
A data store, actually creating a huge data store.
Yeah, it's a data store. And we did it with ESP because we didn't want to develop software. We want to configure it. We want to be able to do innovations and use cases in a very short time. In the older environments, when you add a sensor or something innovative, you get lots of develop time before you get any data out of it. And this kind of use cases we do in this I don't know exactly, but we have done some in 5 days, 10 days, 15 days. Some things that otherwise would take a half year.
Wow. All right. So really accelerating your innovation cycle. That's actually what's happening, because you are using the software which is there and you are configuring together with us on how to deploy it. Actually.
Yeah, and we want to be able to connect any sensor. Any. It doesn't matter. We will. Our environment is diverse. So if we want to build a data collection system, we have to be able to get all the sensors.
Yeah, from every type. Yeah. And Rick, you had some pictures to share with us, also two small short videos. I saw one passing by. Can you just illustrate what's happening there?
Yeah. So before you saw the raw data, so to speak. So you saw the whole environment, and this is those 655,000 data points. And in the end, what you saw just before, you saw that the model was able to detect the ship, that we were able to determine its dimension, in which channel it was sailing, and so on. We got all the relevant information out of this LiDAR sensor. And it's only this relevant information that we send via 4G.
All right, so only the relevant information is there to see. And we just saw the next slide already. They're tipping in.
Spoiler.
That's the spoiler. All right, and then the management of RWS wants to have a visualization report.
Yeah, exactly. They don't want to look at this, but they want to have a nice report of what's going on.
Please explain. What can we see here?
So what they see here is an overview of what's happening on the Frisian waterways. So they can see at what time a ship passed the LiDAR sensor, in which channel it was, direction, its dimension, but also its speed and its classification.
With the operators having in mind, because it's them actually who has to intervene in some case. How does this work, Casper? Why are you in need of this kind of visualizations?
Well, you can imagine that water moves up and down a little bit. Some ships are higher and lower, so it might be more efficient to build a higher bridge so that traffic can go through, which is better for the economy. Or some places there is a high bridge where it just isn't needed, so you can, the next iteration of the bridge might be a little bit lower and save a lot of money. And the main thing where we look at is what type of ships are going through the canals. So because of the LiDAR system, the last column is the class. And basically what our asset managers want is a pivot table. How many ship types go through at which time, when is it, I got distracted a little bit.
Yeah, but because
when is it,
when is it to talk in the mic?
Yeah, I do. Sure. But so when at what times are ships going through that route, and which types are those?
Yeah. So this kind of information is very useful for multiple reasons. Yeah. Let's have a look in our chat, because I can imagine our audience has some questions. Heren, can you take us to the chat?
Yes, Arthur, let's go to the chat. We only have time for one question, but I think it's a great question. It's a question from Hans Funke. Hans, can you maybe open up your mic and put on your video and ask the question?
Yes, of course, Hera. Thank you. Well, I see a beautiful example of using IoT. I love this example very much. So thanks for presenting, you both. My question is actually, how do you see the future of IoT within the RWS Rijkswaterstaat?
Wow.
Ooh, it will get bigger and bigger. All our objects are getting smarter. So we can use this data for how do you call it in English?
In Dutch?
maintenance purposes. So lots of data. It's getting more and more. Cars are getting smarter. All this data has to be combined. You don't want to combine data after a half year. No, you want to do it real time to add value to this data. So that's our vision.
That's a big ambition. Thank you. And is there any specific kind of project which you are thinking of, which will be the next, or?
Yeah, a lot. Yeah,
all of them. Yeah. Okay.
Rob created quite a challenge, but we have several projects already on the go. This is what we saw today was LiDAR, but we also did a startup, a proof of concept for radar systems. We are doing road measurement systems where we measure how not only where cars are driving, but are they driving in a lane which they are allowed to drive in. We're thinking of alerting systems. We're combining ships with road systems. It's not going to end. We're doing predictive maintenance. Yeah. So basically not only that we measure how long equipment has been used and when it's, let's say, the mean time between failure, but we are also going to do predictive maintenance where we actually measure vibrations and power harmonics and basically determine if something is in need of a fix before it breaks down.
And you forgot our main
task. The water. This all started with the water management system of Rijkswaterstaat. So basically, it's a system that consists of 2,000 sensors placed all over the northern part of Europe, and that's where we measure all the water levels, the water flows in rivers, in the seas, and it is basically a decision support system to either determine to close some locks or...
I get it. So 2,000 sensors, the northern part of Europe, because we are interconnected, of course, with all the other waterways and...
Yeah, and we get then we're not even counting our colleague countries that give us data, and we give them our data, so they can measure their own rivers and seas also.
And that was your vision, Rob.
And that's where we started. We don't want to build another specific data collection solution. No, we want to build a system that we can use in all domains.
In all domains. Thank you very much, Rob, Casper, for coming over here to Huizen in the Netherlands. Rick, for commenting on your help in this project. This is an awesome project as well. So thank you very much. And now I will give a big thank you also to the audience, to all people here in this cafe joining this great stories with those entrepreneurs, you might say. Actually, we are talking here about pioneering in the field of innovation. So, smart health, smart farming, smart water management, smart any kind of infrastructure, we all saw it. So, what's next? Of course, we will have a next cafe, but next Monday we'll launch our first podcast series together with BNR, one of our radio stations here in the Netherlands. And there we will visit RoboHouse on robotics. We will visit KNVB, our football and soccer association. How do you call it, Bert? KNVB, the soccer. And last but not least, Amsterdam UMC. So stay tuned for next Monday. Then we'll have this launch, and then in September, the 9th of September, we'll be back with our next cafe, and that will be on synthetic data. What are the values of synthetic data in the process of innovating with data and analytics? Thank you very much. Have a great evening. Have a great day, and see you hopefully soon. Bye bye.